So welcome to this video on AP Statistics, Chapter 7, Lesson 3, Practice. So we're going to go ahead and take a look at starting with the multiple choice. So number one, the distribution of PSAT scores for students at a large high school has a mean of 1,020 and a standard deviation of 110. Let X bar represent the mean PSAT score for a random sample of 30 students at this high school. Which of the following calculations will give the approximate probability that X bar is more than 1150? Okay, so first off, we need to calculate. Basically, what they're asking is how do we calculate the z-score? Remember that the z-score is the value minus mean divided by the standard deviation. Okay, well, in this case, the value is you're looking for X bar is more than 1150. Okay, so that means, so you're saying X bar is greater than 1150. So converting that into a z-score, well, we'll use 1150 for the, well, first off, let's write down the symbols. So we got X bar for the value. The mean is mu X bar. The standard deviation is sigma X bar. But we know that mu X bar is equal to mu because it's an unbiased estimator, X bar. And we also know that the sigma X bar is sigma over square root of n as long as the 10% condition is satisfied. And so that's true. Then we can use the formula X bar minus mu over sigma divided by square root of n. Okay, so we can use that. And so all we got to do is just plug in the numbers. So 1150 for my X bar right there. And then we have minus the mean. They mentioned the mean is 1020. And standard deviation is 110. And they got a sample of 30 people, so that's your n. Okay. Over 110 over square root of 30. Okay, and so it looks like the answer is A. All right, so we just want the probability that Z is greater than that. All right, number two, suppose the sampling distribution of a sample mean for samples of size 25 is approximately normal with a mean of 100 and a standard deviation of 10. Which of the following is the population standard deviation? Okay, so we know that assuming that the 10% condition is satisfied, meaning that 25 is less than 10% of the population, well, then we know that this is the sampling distribution. So we know that this, let's just say it's you have the sample mean, right? Sampling distribution of sample mean, so that's X bar. And so then the sigma X bar, as we mentioned, is sigma over square root of n. There you go. And so you know that they said sigma is 10, or they said that the sigma X bar is 10. So we have 10 is equal to sigma over square root, and we have a sample size of 25. All right, and so we have 10 is equal to sigma over 5, and then you times 5 on both sides, and you get sigma equals 50. All right, so we got number 3. Before Debbie begins pumping gasoline into her car, she predicts the number of gallons she'll need to fill up. After pumping, she records the actual amount of gasoline needed and calculates the difference, actual minus predicted. The distribution of the differences is skewed right, with a mean of 1.7 and a standard deviation of 2 gallons. This is for the differences, okay? Actual minus predicted. She wants to calculate the probability that the mean difference is greater than 3 for random samples of size 100. Which of the following describes the sampling distribution of the sample mean difference? So they're asking if it's approximately normal or if it's skewed right. So remember the central limit theorem, right? It says that if the sample size is large enough, even if the original population is largely skewed, or whatever shape it is, the sampling distribution is going to be approximately normal, as long as n is greater than or equal to 30. And that's the large counts condition. Okay? And if the original population is already normal or approximately normal, then it doesn't matter what the sample size is. The sampling distribution will also be approximately normal. But here it says it's skewed to the right. So that means we need the sample size to be large. However, it is large, right? So this satisfies that condition because n is 100 here, right? Which is greater than or equal to 30. And therefore, it has to be approximately normal. So it's not going to be skewed. So it's going to be A or B or C. And then we have to determine what the mean. Well, the mean is going to be the mu x bar is the same as the mean. And the mean, they said, was 1.7. So it can't be C. The standard deviation is going to be standard deviation over of the population over square root of n, and which is, they said it's 2 gallons for the standard deviation here, over square root of n. N is 100, so it's going to be 2 over 10. Square root of 100 is 10, or 0.2. And so the answer has to be B, because it's, you have 1.7 and then standard deviation of 0.2. All right. Let's look at number 4. Jeremy is the owner of a company that has thousands of monthly expenses that are all paid for with online orders. The company sends an average of $1,120 per order with a standard deviation of $700. Over the next 25 orders, he wants to reduce the mean order spent to $400 or less. What is the z-score that corresponds to this target mean? Okay, so first it says he wants to reduce the mean order, so that's x bar, right? He wants that to be $400 or less, so less than or equal to $400. The company spends an average of, so that's your mean, which is equal to your mu x bar, right? And then the standard deviation is 700. That's the population. All right, and so yeah, so what we can do is calculate the z-score. Remember that we said the z-score x bar minus mu divided by sigma over square root of n. So we have 400 minus mu divided by sigma over square root of n over the next 25 orders. That's my n. So here you go. Remember, when you do this in parentheses when you calculate that, okay? And sometimes it's easier to just do the denominator, you know? So it's going to be 400 minus 1120 is negative 720 over, and then we said 700 divided by square root of 25 is 5. So 700 divided by 5 is 140. We got negative 720 divided by 140. We got negative 5.14 approximately. Okay, so the answer is A. All right, number 5. The ideal climbing season for Mount Everest is April through June. During the month of April, over many years, a cleanup team collects a mean of 115.7 pounds of trash per day, with a standard deviation of 9.5 pounds, okay, per day. During the month of June, over many years, the team collects a mean 127.1 pounds per trash per day, with a standard deviation of 8.7 pounds per day. Okay, so one of them is during the month of April, the other one is during the month of June, okay. Let x bar A represent the sample mean pounds collected over 5 randomly selected days in April, okay. And then x bar J represents the same thing but for June. So what are the mean and standard deviation of the sampling distribution of the difference in sample means? X bar A minus X bar J. Okay, so remember that in general, if I have, in order to get the mean difference, right? So let's go ahead and look at it. So if I wanted to do this, right, the difference, well then the mean of that difference is just the difference of the means. Okay. And so all I gotta do is do that. Okay, so that's the mean. So that means that we just have to subtract the two weights here. Okay, so we have to do 115.7 minus 127.1. Okay. Okay, that's going to give you a negative 11.4. Okay. So that means it's got to be either C, D, or E. Now, in order to get the standard deviation, the standard deviation formula I'll write it here, is going to be the square root of the variances squared. So it's going to be sigma squared, variances divided by the number, the sample sizes. So sigma squared A over NA plus sigma squared B, or J, over NJ. Okay? So there's your formula. Now these should be found in your formula sheet for the AP exam. So you don't have to memorize this. So, or at least this one is. You just have to know where to find it, okay? So if I use that formula, then I have square root, and then they told us that the standard deviation is 9.5 for the first one, 8.7 for the second one, and they're both over 5 randomly selected days. So they have the same value of n. So this is nj, and this is na. Okay. Okay, so 9.5 for the first one, so 9.5 squared over 5 for NA. And then for sigma j, it was 8.7 squared over NJ is 5. Okay, and we don't have to calculate it because we just have to compare the answer. So which one's the best answer? This one has the squared on it, so this one has to be it. Okay, it's got to be D. And this one has a minus. It's never going to be a minus here, guys. It's always going to be a plus. All right, so the answer has to be D. Emily is going on a road trip and made a playlist with over 500 songs. Suppose the average length of a song is 3.75 minutes, and the playlist. So okay, over 500 songs. The average length 3.75 minutes, and then the playlist is set to shuffle the songs randomly with replacement. Okay, so randomly with replacement, right? Let X bar F represent the average length of the first 20 songs. Okay, so 20 songs, so that's your sample size. X bar N, at least for F. And then X bar N represents the average length of the next 10 songs. Okay, so N slash capital N is 10. And then what is the mean of the sampling distribution of the difference in sample means? Okay, so all you guys just do is the mean. So again, the mean of this is just the difference of means. Okay, and I mean, they already told you, so it's got to be 3.75. This is supposed the average length of a song is 3.75. Okay. So yeah, if this is the average length of the song is 3.75. Oh, so another thing too is that I can also rewrite this as this. So let me rewrite this as mu x bar f minus mu x bar n, right? Which is the same thing as mu f minus mu n, right? But we know that mu x bar is equal to mu, regardless of whether it's mu x bar f or mu x bar n. And that's because, you know, it doesn't matter. It's either the first 20 songs or the next 10 songs. It's still the same population, okay? So it's same population. So same population. So it's not like it's a different population or anything like that. Different sample size, yes, but it's the same playlist, same stuff. So it's going to be mu. So that means it's going to be mu minus mu, which is going to be 0. So it's going to be 3.75 minus 3.75, basically, equals 0. Okay? Hopefully that made sense. So it's going to be A. Okay. So for your response, All right, so Kia has completed all 25 quizzes in science class this year. Her mean score on the quizzes is 87.5, and the standard deviation is 6.7. Okay, our 87.5 and 6.7 statistics or parameters. Okay, well, it says all 25 quizzes, right, and in science class that year, and they're saying that the mean is that. So these are parameters, guys, because it's all is population, right? So all 25 quizzes, it's all population. Okay, so parameters, they are both parameters. Because they are characteristics of a population. Of population of all 25 quizzes in the year. And so the mean is 87.5. They want us to define with the symbols. The standard deviation is 6.7. Okay, so you want to use symbols for each. Describe how Kia had create the sampling distribution of the sample mean by selecting samples of size 2. Okay, so we're just kind of, this is in words. How do we create the sampling distribution by using samples of size 2? So we would have to list out all the samples of size 2, right? All the possible samples. So she should list all possible samples of quiz scores of size 2 and calculate the sample mean, or the mean of each sample, I guess you could say. The mean of each sample, then create a dot plot of the results of the sample means. Okay, that would be the sampling distribution of the sample means. What are the mean and standard deviation of the sampling distribution? Okay, so then in that case, notice that the okay, so then notice that the sample size is 2. Okay, so n is 2 in part B. All right, so then in that case, the mean, remember that the mean of the sample distribution sample means is going to be the same as the original mean. So it's still going to be 87.5. However, the standard deviation, if the 10% condition is satisfied, is going to be sigma over square root of n. And sigma is 6.7, and then over square root of 2. And that's going to give you about 4.738 for the standard deviation. All right, so part D, what condition must be met to use the formula for the standard deviation in part C? This is what I was saying. So it's the 10% condition. Okay, and they want you to check the condition. Well, the sample size is 2, and we can assume that 2 is less than 10% of the, well, actually, we know the population, so let's actually calculate that. The population is 25, okay? So we're going to say, okay, well, we know that 25% or 10% of 25 is is 2.5, and therefore 2 is less than 2.5, and therefore it's true. Okay. All right. So number 8, AP Statistics conducts a census of all AP Statistics students at their high school to learn about their social media usage. One survey question asks, how many different social media accounts do you have? A dot plot summary statistics of their responses are shown. Okay, so we got their information there. It says describe the population distribution. Let's zoom in on this a little bit. Okay. So we just want to describe this distribution here. And this is for the population. So in this case, it looks approximately normal, right? It's symmetric, approximately normal. The mean, well, they tell you what the mean is, so we can use that. They tell you what the standard deviation is, so we can use that. And that, yeah, that's basically it. So it's unimodal. It's approximately normal. So we're gonna say that. So the distribution is approximately normal with a mean of 3.3 and standard deviation of 1.35. Okay. In other words, when you do this, it's you'd say it's normal, and then you get mu equals 3.23, sigma equals 1.35. Sometimes you would see that it's what that means. It's a normal distribution with a mean and standard deviation. Okay. All right. So one random sample of 15 responses is selected. The dot plot and summary statistics of the results are shown. Describe the distribution of sample data. All right, so now we're going to describe this. Okay, well, they give us the mean and standard deviation, but now if I look at this, this looks kind of skewed to the right. See that? So definitely skewed to the right. So the distribution appears skewed to the right. With a mean of 2.53 and standard deviation of 1.3. Okay. Suppose a teacher selects every possible sample of size 15 and record the average number of social media accounts for each sample. What is the name of this type of distribution? Okay. So you're just doing all possible samples and then you're doing the average number. Well, that's X bar, right? So that's it. So that would be the sampling distribution. So this is the sampling distribution of the sample mean. Okay. All right. Describe distribution in part C. Okay, so then what would the distribution look like? Essentially what they're saying. Okay, so what we want to notice is that when we did part B, which is the sampling distribution, this is an approximate sampling distribution, right? This is not the exact because they don't have all possible samples of size 15, right? Um, this is one random sample of 15 responses. Is selected, the dot plot summary statistics are shown. Or let's see, yeah, one survey question asks how many different survey accounts. Yeah, so we would have to do every possible sample of size 15 and then record it. So if we did that, if we were to do that, then it would be the sampling distribution, right, of sample means. And according to this, it would be according to the population, this is the population data. So this is population, and this data is distribution of sample data. Okay, so that's good. And then, so then if I were to do the sampling distribution of the sample mean, then by the central limit theorem is if this is already normal, then even if the sample size is 15, it's this distribution is still going to be normal. Okay. So that means it's the shape is going to be approximately. Okay. Be approximately normal. Similar to the population. With the mean. Now, the mean of this is going to be the same as mu x bar, right? So it's going to be the same as mu. So I really should put it the other way around. So mu x bar equals mu. So the mean of this is going to be the same, right? It's going to be the same as the original mean, which is 3.23, right? Now the standard deviation is going to be different. So we need to calculate that. So let's do that over here. The standard deviation is going to be sigma over square root of n, assuming the 10% condition is satisfied. And then you have the standard deviation original is 1.35. So it's going to be 1.35 over square root of 15. And so that's going to be 0.349. Okay, of 0.349. Okay, so there you go. That takes care of that. So number 9. A corporation offers bonus donations to Girl Scout troops in a certain state based on cookie sales. To determine the eligibility for the bonus, one member is randomly selected from the troop, and their total number of boxes of cookies sold is counted. For Girl Scout Troop A, the number of boxes sold per member is approximately normally distributed, with a mean of 25 boxes and a standard deviation 4.6 boxes. One troop receives the bonus if the randomly selected member sold more than 30 boxes. What is the approximate probability that Girl Scout Troop A will receive the bonus, or a bonus? Okay, so it looks like they're saying that X is greater than 30, right? It has to be more than 30 boxes. So we know that it's approximately normal. So when we answer this question, we know that it's going to be a normal distribution for X, right? And the mean of that normal distribution is given by 25, right? So mean is 25. So, and then standard deviation is 4.6. Okay, so we have 25, and then it goes by 4.6s, right? On left or right. And then they want us to be more than 30 boxes. Okay, so then this would be 29.6. If I add one standard deviation, if I add another standard deviation, that's another 4.6, right? Which is 9.2, so it's going to be 34.2. All right, so it's going to be 30 boxes, which is around here, and we're going to shade to the right, okay? Now we can convert this to a z-score and then use the table, and then, or we can use the calculator. We're going to do both because we want to practice. So the z-score is going to be x minus mu, so it's going to be 30 minus the mu, which is 25, over the standard deviation, 4.6. Okay? Let me write down the formula. So it's x minus mu divided by sigma. All right, so we get 5 over 4.6. Which is about 1.1. Okay? We're going to round it to 2 decimals. Or I'm sorry, let me go back. 2 decimals, 1.09. Okay, so 1.09. Okay, and then we're going to go to our table here. Remember, it gives you the area to the left, so if I want to get to the area to the right, I have to subtract from 1, okay? But we're going to look at 1.09. So 1.09. So it looks like if I go 1.09, looks like the area is 0.8621, okay? All right, 0.8621, and then I'm going to subtract that from 1, okay? So 1 minus 0.8621. The probability that z is greater than 1.09 is equal to that, which is 0.1379. Okay, so this is using the table. So that's that one. Now let's do it with the calculator. So the calculator, you're going to be using the normal CDF. Okay, so normal CDF. And the lower limit is 30, right, according to the graph. The upper limit is infinity, or a big number. So we can use like 1,000 or something like that, or 10,000. I'm just going to use 10,000. And then the mean is 25, and the standard deviation is 4.6. Okay, and if you did that, that would give you about approximately 0.1385-ish. We'll show you this on the calculator. Okay, so I'll show you this on the calculator. So I hit second. We're going to go vars. I'm going to go down to normal CDF, which is number 2. Again, we're going to change that to 30. And we're going to use 10,000 there. Really big number. 25, and then 4.6. Okay, so like I said, about 0.1385. All right, so it takes care of that. And notice that the results are very similar. All right, part B. It says the corporation suggests a new plan. So randomly selected 3 Girl Scouts instead of 1. Okay, so 3 Girl Scouts. That means the N is 3. The sample size is 3 there. Okay, so we just put N is equal to 3 based on that information. And using their mean number of boxes sold. Okay. So the troop will receive the bonus if the mean number of boxes sold is greater. So the mean number of boxes has to be greater than 30. So this time they're saying that X bar is greater than 30. Would troop A be more likely, less likely, or equally likely to receive the bonus? And so what they're saying is basically they want the X bar to be greater than 30. Well, remember that if that's true, then that means that the sigma, the mean of this distribution, is still going to be the same as the original mean, which is 25. The standard deviation, however, is going to be sigma over square root of n. So it's going to be 4.6 over square root of 3. Okay, so 4.6 over square root of 3 is 2.66. Okay, so about 2.66. Well, it's about 2.7. Okay, so notice that 2.7 is less than 4.6. And so what that's going to do is when you make the graph, right? When you make the graph, it's going to have the same mean, but it's going to go by 2.7s instead, right? So it's going to be 27.7. And then another 2.7 is 5.4, so about 30.4. And then one more. We're going to do one more. And that's going to be 2.7, so be about 33.1. And so notice that if you want it to be greater than 30, right? Now you're here, you want to shade to the right. Notice the difference between that and here. Here, it's a greater area than over here. It's a smaller area. And that's because the variability of this, is smaller. And because the variability is smaller, that makes these values, these extreme values, less probable. Okay? And that's the main idea. Okay, so let's go ahead and answer. It would be, I guess we can say that they would be less likely. Okay, so they would be less likely to receive the bonus. Under the new plan. Due to the decreased variability. Sigma X bar is about 2.7, is less than the sigma, which was 4.6. Okay. All right. All right, so number 10. For a state exam, 5th grade students receive scores from 1 to 5. The scores of all 100 5th graders at a small school are approximately normally distributed. Okay, 100. With a mean of 3.2 and standard deviation of 0.5. Okay, so we know that the population size is 100. We know that it's approximately normal. We know that the mean is 3.2, and then the standard deviation is 0.5. So that's the information that we have so far. Okay, so the principal plans to select a random sample of 10 of students and calculate the mean score. What is the largest sample possible, if sample size possible, if sigma over square root of n is used to calculate the standard deviation of the sampling distribution of the sample mean? Well, remember that this formula can only be used if we have the 10% condition, right? And so the 10% condition is that the sample size is less than 10% of the population. Okay, so all we got to do is, well, or we could say less than or equal to, less than or equal to, I guess. Here they use less than or equal to, but technically I would say strictly less than, but either way, you could say less than or equal to, that's fine. And so if you did that, well then we can set n equal to this, right? And so we know that n would have to be less than or equal to 0.10 times 10% of 100. There's 100 fifth graders in the population. And so n would be less than or equal to 10. Okay, so you would have to do maybe 10, 9, or 10 students. Okay, if you're saying it could be equal to. If you're saying it's less than, strictly less than, then technically it'd be 9. Okay, I would be err on the safe side and actually just go less than rather than equal to. But either way, you could say 10. So we could say largest sample size is about 10 students. When sampling without replacement. According to the 10% condition. Okay. All right. Suppose the principal randomly selects 8 students and calculates their mean score. Find the mean and standard deviation. Okay, so we know that the mean x bar is going to be the same as the mean. And the mean we said earlier was 3.2 right here. And then the standard deviation is going to be standard deviation over square root of n. Standard deviation was 0.5, so it's going to be 0.5 over square root of 8. The sample size is 8 there. And so you get approximately 0.177. All right, if instead the principal randomly selects 4 students and calculates their mean score, how does this change the sampling distribution of x bar? The standard deviation will go up because you're going to have a smaller denominator. And a smaller denominator means a bigger number. Okay? So the mean will remain the same. But the standard deviation will increase. Okay? All right. So the average daily temperatures of March in Charlotte, North Carolina, follow an approximately normal distribution with a mean of 52.1 and a standard deviation of 10.5. Okay, so we got mean, standard deviation. Calculate the probability that a randomly selected day in March will have an average temperature between 45 and 60. Okay, now here they're talking about, remember, average daily temperature is X, okay? So they're talking about average daily temperature, that's X, between 45 and 60. So they're looking for the probability that X is between 45 and 60 degrees Fahrenheit. Okay, and we know it's normally distributed. Actually, let me just do this over here to save some room. So we can use the normal CDF function for this, but let me just draw out the curve, just a small one. So the mean is going to be 52.1, It's going to go by 10.5s. So we're going to go 10.5 here. That's going to be 42. And so it's going to be 41.6. I'm going to go one more on the other side, 10.5. So 52 or 62, so 62.6. And so it's going to be between that. Okay, so it's going to be 60 degrees here, 45 here. And so this is the area shaded, right? And so we're going to convert this to z-score. So you could do that, I mean, if you want. But actually, I'm not going to do that. So if you were to do the z-scores, you would compute two of them, right? Just for the sake of space, I'm not going to do that here. But you would calculate the two z-scores, and then you would look both of them up on the table here, and then you would subtract the two areas from this table, okay? So that's how you would do that. But I mean, we're going to use this. We're going to use the graphing calculator here to save some room. So you got normal CDF, and you got your lower is 45. Your upper is 60. Your mean is 52.1, and your standard deviation is 10.5. Okay, so using this, you get 0.5246 approximately. Okay, so part B, from the weather records of the past 100 years, Dean selects a random sample of 5 days in March and calculates the mean of the average temperatures for the sample. This of X bar, sample X bar. Describe the sampling distribution of X bar. Okay, so now because the original is normally distributed, that means that the sampling distribution is going to be normally distributed, regardless of the sample size, whether it's 5 or whatever. Even if it's way less than 30, it's still going to be approximately normal because the population is normal. Okay, so that's important. So the distribution it would be approximately normal. With a mean of, so the mean is going to be the same as the original mean, so it's still going to be 52.1. And the standard deviation, we'll need to calculate that. Use standard deviation over square root of n. Okay, so standard deviation was 10.5. Divide that by the square root of 5 days. That would be 4.696, around there. And standard deviation of 4.696. These are both degrees Fahrenheit, by the way. Okay, now calculate the probability that a random sample of 5 days in March will have a sample mean temperature less than 40. So we want the probability that X bar is less than 40. Okay, so again, we have the bell curve, right? But with the same mean, but now it's going by 4.696. Okay, so just gonna do that real quick. So 47.404. Okay. Go another one here. 42.708. And about 38. Okay, 38.02. So we can see that the area is going to be really small, guys. For it to be the mean temperature less than 40, that would be like over here. So that's X bar equals 40. It would be a pretty small area. You can already see that. So we're going to use a normal CDF. I'm going to use the lower is going to be negative infinity. So we can say like negative 1,000 or something like that. The upper is going to be 40. Mean is 52.1. Standard deviation is 4.696. Okay, and you would get a probability of about 0.005 approximately. All right, so let's look at number 12. All right, so an AP Statistics teacher recently gave a test to all 167 of her students. Here's the dot plot of the scores and the summary statistics. So describe the distribution. So if you look at the distribution, it looks to be skewed to the left with a mean of that and a standard deviation of that. Okay, so it's skewed to the left with a mean of 81.92 and a standard deviation of 15.62. Okay. Suppose the teacher selects random samples of 5 test scores and calculates the average of each sample. What is the shape of the sampling distribution for the sample means? Now, this is where we use the central limit theorem. Now, because this is skewed and the n is 5, which is less than 30, that means it's not going to be normal. Okay, so the shape is not approximately normal, but it would be less skewed. Okay, so the shape would not be approximately normal. It would be less skewed to the left than the original population. Okay, so it's going to be skewed left, but it's going to be less so, okay, according to the central limit theorem. Suppose the teacher selects random samples of 35 test scores. Now we're doing this. So now that n is equal to 35, which is greater than or equal to 30, so it passes. So now the shape is going to be approximately normal, okay? Shape is approximately normal. According to central limit theorem. Central limit theorem applies here. All right, so number 13, Amazon Web Services is known for having low latency times for their servers, which is the amount of time it takes data packets to travel from one server to another. Suppose that one AWS customer from California recorded the latency times for 1 month. The distribution of these latency times is strongly skewed to the right, with a mean of 148.1.8 and a standard deviation of 69.0 milliseconds. Suppose AWS randomly selects 50 of these latency times and then calculates the mean of the sample x bar. What is the shape of the distribution? Well, it's going to be approximately normal, right, because of the central limit theorem. Okay, so n equals 50 greater than or equal to 30. It passes. So it's going to be approximately normal according to the central limit theorem, CLT. What are the mean and standard deviation of the sampling distribution of x bar? Okay, well then the mean is just be the original mean, which is 141.8. And then the standard deviation, if it passes the 10% condition, can be given by this, which is 69 over square root of n is 50. Okay, and that's going to be about 9.76 around there. Yeah, around there, 9.76 milliseconds. Okay, let me double check that. Just want to double check it, make sure we're good. Okay, yeah, that's what I got. Okay, So for a random sample of 50 latency times, what is the probability that the mean would be less than 130 milliseconds? Okay, so we know that n is 50, right? According to this. So let me do that. So n is 50. And we know that the mean would be less than. Okay, so that means x bar. So with the probability that x bar is less than 130. Okay, so we know it's going to be approximately normal. The mean is 150. The standard deviation is going by 9.6s, 7 sixes. So 159.76, etc., etc. On the left side is going to be approximately 140, right? So one. Let me subtract that out here. So 150 minus 9.76. So it's going to be about 140.24. Okay, so 140.24. So then it becomes 130.48. Okay, so 130.48. So it looks like it's going to be small. It's going to be right here. X bar is 130. So there's going to be a tiny area. Okay, according to the graph that I have. So maybe 0.1 or less than that. Okay, so let's go ahead and calculate that. So we're going to use normal CDF. We got 100, or our lower is negative infinity, like negative 1,000. Actually, let's do even more than that because this is in the hundreds. So let's go negative 10,000 just to be safe. Our upper is 130. Our mu is 9.76. Let me just do it over here. And our standard deviation is 9.76. Or no, our mu is, I'm sorry, I got the wrong thing here. 141.8. Or did I mess up the number here? I don't know how I got 150. How did I get 150 there? 141.8. I'm sorry, guys. 141.8. I don't know how I got 150 there. I have no idea. Sorry about that. Okay, so 141.8 minus 9.76 is 132. Okay, so 132.04. So 122.28. Okay. So it's not as small as I thought it was going to be. So I want to make sure that's clear. 130 is going to be like here. Because I thought it was going to be about 0.0 something or 0.08, 0.0 whatever. But it looks like it's going to be higher than I thought. So, all right. So, okay. So we can go ahead and calculate that. And it turns out if you calculate that, you get 0.1131. All right. Okay, so let's look at the next problem. Part D, suppose AWS customer had selected a random sample of 10 latency times instead of 50. How would this change impact the following? All right, the shape would be the fact that it's going to be less than 30 now, because n is now 10 is less than or equal to 30. So it would fail that condition. So because it fails that condition, it's going to no longer be, so not approximate normal. It's no longer going to be approximate normal. In this case, it would be, remember that the original is strongly skewed to the right. That means that this is going to be slightly skewed to the right. It would be slightly skewed to the right. Okay, and then the center will be the same. The center won't change. Center would still be 141.8. And standard deviation, now that's going to change, right? So the standard deviation would increase because you're decreasing the n. So it would be sigma over square root of n, which would be 9.76. No, is it? Yeah, is it 9.76? Hold on, let me double check. 69 over square root of 10. Let me do that. Okay, so it'll be about 21.8 around there. 21.82. Okay, so it would increase. All right, that takes care of that. According to the Bureau of Labor Statistics, the distribution of salaries for management positions is skewed to the right, with a mean of $117,000 and standard deviation of $37,000. Suppose we select a random sample of 40 adults and calculate the average salary. Describe the sampling distribution. Okay. Okay. So again, we've done this before. So because it's 40 adults, right? N equals 40. Now it's greater than or equal to 30. So that means, and even if this is skewed to the right, it's still going to be approximately normal, right? Because of the central limit theorem. So approximately normal due to central limit theorem. Now calculate the probability. Okay, so again, random sample of 40 adults. So n is 40, and we'll have an average salary. Okay, so average salary. So the probability that the average salary is less than 100,000. All right, so here we go. You got this. This is X bar. You have 100,000. No, the average salary is 117,000, and standard deviation is you're gonna need to calculate the standard deviation. Okay, so let's do that. So standard deviation sigma x bar is equal to the standard deviation, which is 37,000, over the square root of 40 adults. Okay. Oh, I forgot to do this here. I forgot to describe this one with the mean. Okay. Describe the sampling distribution of sample mean. So this should be, I should be more specific here. With a mean of 117,000 and standard deviation of, well, let's calculate that. I should have calculated this here. This is why I was saying 37,000 over square root of 40. So let me actually calculate this up here instead, because this is the order in which I should have calculated it. And you get about $5,850.21. Okay. Okay, so and standard deviation of. Okay, so there's that. So then we're going to go by that. I'm not going to do all the numbers, okay? But I am going to do the 100,000. So it has to be less than 100,000. So that means that the area, when we do the normal CDF, is going to be negative, really big number, guys. Okay, so we have to use a number bigger than 10,000 because these numbers are in the 100,000s. Okay, so just be careful. So let's just do negative 10 to the 9th power. Okay, just to be safe. And then the upper is 100,000. 1, 2, 3, 4, 5. That's 5 zeros there, and then this is 9 zeros. So we should be okay. Then the mean is 117,000. Standard deviation is that 5,850.21. All right, and so when you do this, you should get a really small number, 0.0018. Okay, so a frustrated employee at a large company believes that people in management positions are being underpaid. The employee selected a random sample of 40 management positions from the company and found a mean salary of 100,000. So that's what they got. Does this result provide convincing evidence that a mean salary is lower? Um, well, and this is what we just calculated, guys. That is less than 100,000. It's such a small probability of that happening. And remember, our cutoff is 5%, right? So, so we're going to say yes, since 0.0018 is less than 5%, right? Which is 0.05. Then we can say there is convincing evidence. So we can say, yeah, there is convincing evidence that mean salary is lower than national average. Okay. All right, so number 15, the distribution of the number of text messages received per day by all students in the school is skewed to the right with a mean of 25.3 and a standard deviation of 11.2. The first hour creates a simulated distribution, taking sample size 16, calculating the average number of text messages received. The second hour AP class creates by repeating taking samples of size 64 and doing the same thing. So you want to compare the shape, center, and variability of these two different classes. Okay, so we know that the center is going to be the same because it doesn't matter about the sample size. The standard deviation is going to be different. The one with the smaller standard deviation will have a larger, or the one with the smaller sample size will have a larger standard deviation. So that's going to change. The shape, the one with a sample size of 16 is going to be not normal because the original population is skewed to the right, and 16 is less than 30. Now 64 is greater than 30, so that means it's going to be approximately normal. Okay. All right. So this one N1 N1 is 16, which is less than 30, so it fails that test. N2 is 64, which is greater than or equal to 30, so it passes the test. Okay. Okay, so the shape for first hour is slightly skewed to the right. Okay, and the shape for the second hour is approximately normal. Okay, and then we'll describe the means. So both will have the same means. Okay, so both distributions have mean of 25.3. The standard deviation of first hour is larger. So we're going to calculate that. So let's calculate that over here. Same sigma 1, sigma 2. So it's going to be sigma over square root of n. So 11.2, what's a sigma? Okay. Over square root of 16. And this is 11.2 over square root of 64. Now 64 is 8. So it's 11.2 divided by 8. This is 11.2 divided by 4. Okay. 2.8. 2.8 and 1.4. Okay. 2.8 then that of then the standard deviation of second hour. Okay. All right. And then it says in which sampling distribution would you be more likely to observe a sample mean greater than 30 text messages? Okay. So I'm going to say decreased variability. If you have a decrease in variability, that's going to make a less probability that something happens. Okay, so decreased variability, or I think I said the reverse. The decreased variability increases the probability that something's going to happen, or that you get a particular value. Okay, because if you think about it, look, if something is wide, and then you have a certain value, it's going to be a decent probability. If something is skinny and you have the same value, it's going to have a smaller probability. See that? Smaller, larger. So decreased variability. Um, decreased variability means wider. Um, increases the probability. Okay. Therefore, uh, it would be more likely for 16 students, for the 16 student sample, to have a mean greater than 30 than for a sample of 64. Because the standard deviation for 16 students is um, is greater. Okay. All right. Let's look at the next problem. All right. So SAT scores for high school A are approximately normally distributed with a mean of 1240 and a standard deviation of 105. SAT scores for high school B are approximately normally distributed with a mean of 1200 and standard deviation 125. A random sample of 15 SAT scores from high school A is selected and the sample mean is calculated. A separate random sample of 12 from high school B is selected and the sample X bar B is calculated. Okay, so we got NA for high school A is 15 and NB is 12. Okay, according to that. We got mu A is 1240. Standard deviation A is 105. And let me move this over. Okay, I got that. And then mu B is 1200. Sigma B is 125. Okay, so we need that information. They're both approximately normally distributed. To describe the shape, so then in this case, the shape is going to be still approximately normal because both of them are approximately normal. Okay, so the shape both population distributions are approximately normal. Okay, what is the mean? Okay, so mu x bar A minus x bar B. It's going to be mu A minus mu B. So you're going to subtract them. So 1240 minus 1200 is going to be 40. Done. Of course, we want to interpret. Okay. So if you want to interpret it, we say for many samples of size 15, from high school A and size 12 from high school B. The average difference is about 40. It is 40. Okay, now we're going to do the standard deviation. So standard deviation, so be sure to check 10%. Okay, so 10% condition. Let's check that real quick. So we want to see that, we want to know that NA is less than 10%. So say 15 is less than 10% of all high school students. Of all high school students in A. Okay. I'm going to say 12 is less than 10% of all high school students in B. All right, so check for both. So standard deviation. Okay, so let's write the formula for that. So the formula for the standard deviation, let's put it outside here, of x bar A minus x bar B is square root of sigma squared A over NA plus sigma squared B over NB. Okay, so we're going to be using that formula. Sigma squared A is 105, so it'd be, or sigma A is 105. So 105 squared over, and then NA was 15. This is a squared, by the way. Plus, we got 1 sigma squared B, 125 squared over 12 for the NB. Okay, you can calculate that. And it's going to be 45.134. Okay. All right, so now let's look at the next one. So what is the probability that a sample mean of high school A is greater than the sample mean of high school from high school B? So the probability, so if they want this to be greater than B, then that's the same thing as saying x bar A minus x bar B is greater than 0. Okay, that's exactly what we're looking for. We want this to be greater than 0. And we know that because it's normally distributed and all that, this is x bar A minus x bar B. That the mean we calculated was 40. And the standard deviation was 45, right? So we said 45.134. Yeah. So it's going to go by 45s. So when I subtract 45 here, let's see, 40 minus 45.134. That's negative 5.134. Okay, so negative 5.134. And then here is going 95.134. All right, so then in that case, we want this to be greater than 0. So 0 is here. We want it to be greater than. Okay, so it's the area to the right. So we're going to use the normal CDF. Our lower is 0. Our upper is infinity. So really big number. Let's do 10 to the 9th power. You can do 10 with a bunch of zeros, you know. This is already 95, so maybe 10,000 or something like that, or higher. I'm going to do 10 to the 9th power. Mu is 40. Standard deviation is 45.134. Okay, and you should get a probability about 0.8123. All right, number 17. Wordle is a popular online game in the New York Times. To win, you must correctly guess a 5-letter word in 6 attempts or less. 5-letter word. Okay, so the hardest word to date was jazzy. For all people that correctly solved it, the mean was 5.8 attempts and a standard deviation of 0.56 attempts. Can we assume the population shape for a number of attempts to correctly solve Jazzy is approximately normal? Why or why not? Well, based on this information, you can see, okay, it says 6 attempts or less, right? So, and then the average was 5.82. So if it took them 6 or less, right? So that means this is 6 right here, or less. The average is 5.82, right? And that's what their average was. And their standard deviation is really small. So that means that some people, that if the standard deviation is that small, that means most people are near the 5.82. And that means a few people are far away from it. And so it appears that it's going to be slightly skewed to the left, where most people are here and then very few people are here. Okay, so you can see that the shape is not approximately normal. Okay, shape is skewed to the left. Since the highest number of attempts is 6, right? That's what they were saying. And average is 5.82 with small standard deviation, 0.56. Most people scored around 5 or 6, and very few a small amount, and very few a small amount. Okay. So B, separated random samples of 32 AP Stats students, 45 AP Calc students who correctly solved Jazzy. The average number of attempts to solve will be calculated, assuming both groups have a mean of 5.82 attempts and a standard deviation of 0.56 attempts. Describe the sampling distribution of X bar S minus X bar C. Okay. So we'll do the shape. It's going to be approximately normal. And the reason is that NS, which is 32, is greater than or equal to 30. And C for calculus is 45, which is greater than or equal to 30. Okay? And then the center, the mu X bar S minus X bar C is mu S minus mu C, which is, well, it should be 0 because it says that you're assuming that they both have 5.82, right? So the difference should just be 0. All right, and they both have standard deviation of 0.56, right? So let's do the variability. Okay, so the variability is going to follow this formula. Now here they have the same standard deviation, so really I'm just going to use the same number. So it's 0.56 for both, right? Over 32, and then 0.56 squared over 45. So it's about 0.129. All right, and then they want you to find the probability of that. So I'm just going to do a quick graph. So we know it's going to be, this is X bar S minus X bar C. This is going to be the mean of 0. It's going to go by 0.129s, okay? We want it to be less than or equal to negative 0.3. Okay, so 0.129. Okay, so anyways, we're just going to do negative 0.3. It's going to be a small probability, right? So the area to the left is negative infinity. The area to the right, or the lower is negative infinity. The upper is negative 0.3, and we got our mean and standard deviation. Okay, so it's going to be normal CDF. Lower equals negative 1,000 or negative infinity. Upper is equal to negative 0.3. The mean is 0. Standard deviation is 0.129. And now you get about 0.0100 approximately. Okay, suppose that the sample mean for the AP Statistics students is 5.1 attempts and the sample mean for the AP Calc students is 5.4. Does this result provide convincing statistical evidence that AP Stat students can correctly guess the word jazzy in fewer attempts than AP Calculus students on average? Okay, well, we said that the probability, we said we said 5.1 minus 5.4 is negative 0.3. And we calculated the probability that that's true, that that's less than or equal to negative 0.3 to be 0.0100. And therefore, that's such a small probability that's less than 5%. So we can say yes is very, yes. Yes, since 0.0100 is less than 0.05, it's unlikely to have that difference or lower just by chance. There is convincing evidence. Okay. All right. So Pratham and Raghav play a puzzle game on their computer every day during class. After many, many games, it has been determined that Pratham's mean time to solve the puzzle. Okay, so we have Pratham is 82.5, standard deviation of 15.2, and Raghav's time to solve the puzzle is 85.8, and standard deviation is 17.3. Suppose a random sample of 30 games from each player selected, and the sample mean are calculated. So suppose that x bar p minus x bar r is 2.1. Give a possible sample mean for each player. Okay, so I mean we could say, okay, we could say, I don't know, we could say, I don't know, if we say xp is that number 85.8, you can make up different values, guys. You just have to make it 2.1. And then x bar s or x bar r is 83.7. Then yeah, so then x bar p minus x bar r, I keep saying s, is 85.8 minus 83.7, which is 2.1. Okay, so that's just an example. Raghav found that the standard deviation of the sampling distribution for x bar p minus x bar r by calculating that. Okay, and then Pratham found the standard deviation by calculating the plus. Okay, so this one had plus, this one had minus. Explain each of their mistakes and find the correct standard deviation. Okay, so Raghav needs to correct the minus. Okay, needs a plus, needs to add the values. And then let's look at Pratham. He needs to square. He needs to use the variances. He needs to use variances. Square the numerators. Okay, now the probability is approximately 0.0995 if you were to calculate that, interpret that probability. Okay, okay, so the probability, and you're doing the mean difference in the times, right? that the mean from Pratham is greater than by 2.1 the mean of Raghav's times, right? So the mean um, is at least 2.1 greater. Raghav is 0.00 or no 0.095. Sorry. Okay. All right. Yeah, it's approximately right, so it's not exactly. All right, so let's look at last problem here. Number 19. According to a recent study, drinking coffee is becoming more popular among younger Americans. American adults age 35 and older report drinking their first coffee at an average age of 19 years old. Okay, so older Americans is about average is 19. Younger Americans average is 15 years. A small committee with 500 adults age 35 and older and 350 adults aged 18 to 24 wonders if this is true, so they plan to select random samples. What sample sizes are required for each group so that the shape of the sampling distribution x bar minus 1 minus x bar 2 is approximately normal? Explain. All right, so for the 35 or older versus younger, right? So 18 to 24, you would have to do 10% condition, right? Or not the 10% condition, the large sample, the large counts condition. I guess we could say for both. Okay. Let's just say for both. Okay. For both groups, the sample size must be at least 30. Um, for distribution x bar 1 minus x bar 2 to be normal, to be approximately normal. What's the sample size restriction for each group to use the formula for calculating the standard deviation? Now, this is the 10% condition now. And now we can kind of distinguish between them. So 35 or older. So 35 plus, and then 18 to 24. Okay, so the 35 plus, we have to use the fact that there's 500 of them. And so 10% of 500 is 50, okay? And then 10% of these guys are 350 is 35. Okay, so we would need this is the largest amount. Okay, so the largest amount, so n would have to be less than or equal to that. Okay, so max amount of adults. Okay, and then this is the maximum amount of adults. Okay, so that's the largest that you can have. You have to have less than. For me, I would say less than, but here you could get away with saying less than or equal to. A community member suggests sampling 40 from each group. What condition would this violate? This would violate the 10% condition. So n equals 40 would violate the 10% condition for the group of 18 to 24. Since it would be greater than 10% of the population. All right, guys, that's going to do it for the video. Hope you found this useful and informative. And as usual, I'll see you in the next one.